The views discussed in this conversation are the views of individuals and not of Arrington Capital. This podcast is provided solely for informational purposes and is not financial, legal, tax, or investment advice. The participants of this podcast are not recommending any particular security, protocol, token, financial instrument, or other tradable asset or any investment strategy. It is not offering to sell or soliciting to buy any security or asset.
Hi, everyone, and welcome to the Pirate Pod from Arrington Capital. I'm really excited today to have Shady from Holonym on with us. Thank you for joining us. Holonym is rather new to the Arrington portfolio. We invested earlier this spring, so they've been with us for a couple of months. At a very high level, what they're doing, and we'll unpack this as we dive in, is security based on humanity, basically proving that you're a person or a wallet as a protocol. The team thinks that there's huge potential when you put ZK and MPC together, and we're going to dive into that a little bit. But first of all, we always like to explore our founders and how they got into this space. So Shady, can you share a little bit about yourself? And then I also want to talk about how you and Nanek met, your co-founder.
Yeah, absolutely. If I'm to share the littlest amount, it's that I'm a recovering academic. Actually, didn't know much about crypto or Web3 when I was working with the technology as a PhD student at Georgetown. And at the time, I was working on a institutional data sharing initiative. We were building predictive models for cognitive age in developing adolescents. And to do that, you need a ton of data. You need data from different age groups, different cultural settings, different environments, etc. And so it's really difficult to do this without some form of international collaboration. And it's interesting because when you look at science today, it's science happening less and less in small rooms, and it's happening more and more in a decentralized, always online manner. So to solve our problem where we wanted to bring all of this data together from different institutions across different countries that had different regulatory requirements over what kind of data could be shared and how it could be shared, we ended up using IPFS. But how we got to that was actually a bit of a fun story. So at the time, I was dealing with a lot of paperwork trying to get different labs to sign and agree to use different cloud platforms so that we could aggregate all this data. And it wasn't working. And I knew that I had a certain amount of time to defend before my grant was expired and the clock was ticking. But Juan Benet came to my rescue, or at least his work did, and discovered IPFS. And so we organized a hackathon as part of like a larger brain hack hackathon. And this is something I ended up I think doing a lot in my career, where if I'm out of ideas on how to solve a problem, just organize a hackathon and smart people will come find you and help you solve these problems. And that's exactly what happened. So that's where Nanak and I met. We hacked together on a project where we actually coined the term DeSci. This was before anybody else was talking about decentralized science. I think it's like something that's starting to get a lot of traction in space. But yeah, it came from there. It came from that hackathon project. We added IPFS support to an open source repository called DataLad that allows you to, it's a kind of like a very Web3 type software. They don't know it though. That allows you to pull data from distributed archives across different labs. So you can build like really large, scientific data sets to answer pretty much any question you might have from just open source data, which is pretty cool. Very highly valuable data. And that's when things really got interesting, actually, once I figured out that this technological philosophy existed and that the solutions are mature enough that you could actually build stuff with.
Do you think that many founders find each other in hackathons today? What year was this that you and Nanek met?
Yeah, this was in 2020. Yeah, this was December 2020, actually.
Okay.
I think I would say, yeah. I think a lot of the hackathon culture that at least the Ethereum community has embraced, I think it acts as kind of like a blind dating scene in a way. You don't know who you're going to meet up with or who you're going to find at this hackathon. But
when you were pulling all this data from IPFS, from distributed archives, what like real world problems were you trying to solve? Like, were you working with other researchers in the medical field or AI models? Like, what were you actually, what dots were you trying to connect there early on?
Yeah. So all machine learning algorithms, including LLMs, including all the stuff that we're using today that ChatGPT has popularized and OpenAI has popularized, they're all going to be, it's very difficult to extrapolate outside of the training set. No matter how complex you make your analytics or how deep your neural networks are, or it's very, very difficult to invent new sources of variance, right? Like you're going to be limited to the different ways that the data that you've collected can combine, right? The variance is present within that data. So it's really important to collect very high quality data that captures as many edge cases as possible so that you know what the bounds are of the solution space that you're exploring, right? Like you have some problems you want to solve. In our case, it was what does a mature adult brain look like? What does a mature cognitive profile look like? In the same way that we would, when you would go to the doctor and they have these growth curve charts and they would look at your height and your weight, maybe some other metrics and say, oh, okay, well, you should be, you're 16 years old. And if you're 6'1" and 150 pounds, this should be your BMI or these should be your physical attributes. So we wanted to do the same thing for cognitive traits. And that's something that's very difficult to do without a ton of data. And that data is not able, and that sort of data is not something that a single person or a single lab or a single university even can collect on their own.
Right, because not every lab or university sees all those edge cases. I mean, they're an edge case, right? So any hospital is only going to see some certain amount of them. And so you were trying to, so robust data, including all of the variants and all of the edge cases that could give you solid, good data on what the human brain looks like. Did you accomplish that? How far did you get?
Yeah, we published it. We actually published the data, and it was hilarious because we put so much time and money. I got a grant from the Department of Justice in the U.S. to basically supplement this work and be able to collect some really like advanced, cutting edge magnetic resonance images. So develop some new MRI whole sequences to like pull out, let's call them edge cases, but sources of variance from the brain that we can use to more accurately describe the growth curve of developing adolescents. But it turned out that the brain imaging data didn't explain as much as the behavior did, which is a good sign because it means that if you want to know how your propensity for risk taking or how your inhibitory control and how that changes over time, or other like trait subtle cognitive traits, performative tasks like in say emotion face recognition or impulse control, you can get a far way just with psychometric tests. And these psychometric tests can actually be disguised as video games. So you can have like these like forums or interviews or kind of games where you're collecting this data from children or from developing adolescents. Um, and you could use that for public health use cases where you can identify whether, say, for example, some sort of environmental stressor or pedagogical technique is either impairing or boosting the maturation of cognitive traits. There's a lot of really cool findings in that study.
So question, what was the Department of Justice doing a grant for this? Was it really just under the public health, like trying to figure out like different data elements there?
Yeah, so DOJ took, it's funny, this was under the Trump admin, but they took a very high technology bent in the middle of the Trump admin where they were putting more money into AI, ML, public health determinants of crime, and also not only just about crime, but overall status, like societal status, like markers of societal. And so if you look at any age crime curve, like if you pull data from public databases, you'll see that crime peaks per age, like around ages, it's like 16, 21, and then it like drops off completely. So if you're solving crime, if you're trying to make a safer society, you are going to be investing very heavily in adolescence. You're going to be investing very heavily in education, in teenage support, in sports programs, after school programs. But there's a lot of factors and issues at at play there that in the academic literature people are still trying to sort out. So the DOJ was really attracted to this idea of like, oh, well, maybe we could work together with NIH and other public health facilities to treat maybe crime and the emergence of violence in cities as something that we can proactively treat, like something that, if we have some clear ideas of how to act, maybe we could put money in those things. And a lot of that work, I think, uh, was pioneered by a group of researchers and lawyers at Georgetown, where they show that cognitive behavioral skills training in juveniles reduce the risk of recidivism, so them re-entering the, the criminal justice system. And the effect was so large that it really blew a lot of folks away, and there was this huge kind of interest and investment in this sort of thing.
Okay. And you started out doing this on images. We could have a whole separate other podcast about how this study turned into, a series of questions and answers to sort of understand some of this, less on the images, but then on the other. But you had all this stuff built. So I'm assuming some of the image data collection, if we want to call it that, is how this sort of transitioned to Holonym. So talk about getting through this study and then how this led to Holonym between the two of you.
Yeah. So I finished up my the short story is I finished up my PhD, and this was great because I had the data that I needed. I was able to answer the questions I was looking for. But at that point, I'd whet my appetite in a rapidly emerging unexplored blue ocean space, which is where distributed web technology meets blockchains, meets the giant mass of scientific data and all the stuff you can do with that. So right after I had an opportunity to do a postdoc um, with my PI's collaborator at University of North Carolina in Chapel Hill, and I decided actually to put that in hold in my mind while I explored what Web3 had to offer. So I got a pretty big grant from the Foundation and some other organizations like Ocean Protocol, and that helped me actually create what at that time was calling like a research lab in cyberspace, and that became a DApp. So we did basically like we built this research lab that was built on smart contracts that we would distribute research funding to really talented students that would come in and take on projects. And, I was just messing around really, seeing what was possible, what you could do with a purely digital web native approach to scientific research. And we did some really great stuff. So we actually ended up building a portal a proof of concept that showed how you could offer hundreds of terabytes of free archival for scientific data sets that are at end of life. So what happens to the 2, 5, 10, $20 million research data set that NIH, dumped a bunch of money into at the end of the study? So usually what happens is they take some like very lightweight version of that and they throw it up on the NIH's like website, but all of the raw de-identified data that has a lot of like important stuff in it ends up getting either stored in some hard drive and forgotten about or deleted. Or I think like during COVID, University of Melbourne in Australia, one of the brain research organizations there, institutes, ended up ended up closing. And a lot of the data that they had, there was no plan for what to do with it. So people that were trying to access this stuff suddenly were up a river without a paddle, right? They're like, fuck, where's my data? So what we showed was like, hey, like, blockchains aren't just about currencies. They're not just about arbitrary compute. With Filecoin, you can have a very resilient, decentralized global infrastructure where people are incentivized to maintain data for posterity, for future posterity, for the good of, humanity, for the good of preserving knowledge, this new age of, new Alexandria, new age library of Alexandria. So
do you think the economics will ever be there to just continue hold like the incentive structure that you talk about will ever be there to just have whoever and participating in this system that holds on to every piece of data that the world produces? I mean, it's getting bigger and bigger, right?
Yeah, I really think so, actually. I mean, right now it's a little bit more difficult because there are entrenched infrastructure providers that are competing with Filecoin. I think if you're speaking about Filecoin specifically, I also think that Filecoin is not at the level of maturity that it can be to compete on even grounds with some of these cloud service providers like Amazon and Google and et cetera. I think it will get there because one thing that Filecoin has is resilience. That's something that maybe the AWS or the Googles don't have. Like they're subject to regulation, they're subject to market forces, they're subject to infrastructure. So like a landslide happens in the one area where Amazon keeps all their servers. Whereas Filecoin, the instructions for creating a storage archive for humanity is built into the actual structure of the network. So as long as you have one node, you can always bootstrap from that one node. So it acts as kind of like this super resilient viral force that's just waiting for its opportunity.
Do you think that a decentralized solution sort of overtakes what Google and Amazon have built up here?
It's really tough to say in the next 5, 10, 15 years. I think it's going to be really tough to compete with like huge investments in infrastructure and technology. But if we think about from a perspective of resilience, and I think here's my perspective, really simply stated. Things are becoming very weird. Things that we didn't expect to happen are beginning to happen. And I think that's because of the rate at which technology is changing, the rate at which, livelihoods are, quality of life is increasing, more people participating in the economy. So I would not rule it out that something happens where it becomes very difficult to enforce a centralized business model and compete where you can have basically anyone anywhere in the world providing research or infrastructure or data, support for data infrastructure. So ideally, I think what will happen if with Filecoin is that it can drive costs down the floor. And that's what Amazon and Google are competing against can. The algorithm that Filecoin instantiates its consensus and its ability to have new people run nodes. That algorithm race to floor cost before Microsoft or Amazon can. And with the emergence of AI, like it's one of the biggest untapped areas right now. I think like AI is going to be equal to data in terms of
Yeah, it's fascinating to think about all of these things. Okay, so moving on to Holonym. What is Holonym at its very core, technically?
So Holonym is we're a foundation, we're an organization that was established to instantiate resilient digital rights, what I call natural human rights in decentralized protocols. So what I mean by that is, when we think about rights and natural rights, there's nothing really natural about them. We kind of just take them for granted. Say, okay, we have our constitution, we have our government, we have our police force, and they're going to enforce our right to property. They're going to enforce our right to self-expression, our right to privacy, etc. But there really is nothing natural about that. These rights are put into place by systems that have hardness. Now, there's nothing harder in the world than mathematics. If you're ever going to approach any situation where you have natural rights that are enshrined and kept persistent, it's going to be through something like a blockchain. So we're building a technology called human keys that allows anyone to access digital human rights, the right to security, privacy, proof of personhood, the ability to create, participate in the financial ecosystem, send payments, etc. So human keys are very similar to cryptographic keys as you think of them, but instead of being randomness, they're derived from human attributes, what you know, what you are. So it could be a face scan, it could be security questions, it could be some other source of like offline data that only you have access to. So with human keys, we're able to basically scale the benefits, crypto, privacy, for security, for data ownership, for digital asset ownership, out to everybody. Where interacting with a crypto protocol is as simple as just clicking a few buttons. It feels no different.
And it doesn't always have to be biometrics.
No, it doesn't. It could be, for example, like It could be like security questions that only you know, or it could be like
But
a
isn't that like what the Web 2 stuff is now? This is different, right?
it's different because the individual holds the key, and the key is derived from human attributes. So, it's not secure to you. So why don't we create private keys for passwords? Why don't we do that already? Why don't I take kitty123 and use that as my seed phrase for my blockchain account? The reason I don't use kitty123 because it's more memorable than a seed phrase, like 24-word seed phrase, is because kitty123 has no entropy. It doesn't take me very long to run through all the possible combinations to guess kitty123 by accident. And so this is a problem that WorldCoin had when they were very early in their design process, when they were thinking, okay, well, we want to create some sort of unique descriptor of an individual and tie that to a cryptographic key so that they could send zero knowledge proofs on chain and prove that they're a unique human, so we can give them UBI from AI. And so they went through all the options and they found that the only one that was safe enough were irises, because irises have more entropy in their data, in the way that they're digitized, enough entropy that it would take more time than there exists in the universe to crack any key that you derive from that. So, unfortunately for WorldCoin, we didn't know that it was possible to use something called an oblivious pseudo-random function in OPRF to take any biometric data, regardless of its source entropy, and use that for key derivation, which means that you never needed an orb to begin with.
So how were people bypassing the orb exactly?
The reason they picked the orb is because they wanted to make sure a couple things. One is they wanted to make sure that the same person didn't like put on a mask or like a twin took somebody else's key or someone else's account. But the main concern really is if you're gonna make an immutable descriptor of somebody, if you're gonna say like, for all time, for as long as this blockchain exists, this world chain, as long as this world chain exists, then there's going to be this series of strings that at first glance should be random, but hopefully have, and think of this as an age of AI, right? Like where AI algorithms are pushing the boundaries of what's possible with compute. And we have a string that can't be reversed back to its original data. So that means that if I happen to have access to CCTV cameras, which can resolve an iris in some cases up to 20 feet away, I wouldn't be able to use CCTV cameras to identify on-chain individuals. That's the big thing for WorldCoin. They want to make sure that's never possible. So the reason they picked irises was because the way that they described it was very, very difficult to break or brute force the random string that they're using for proving that a person's a unique individual for the WorldCoin ID system.
But people have been able to do that getting around the orb.
Yeah, so the way getting around the orb works, actually, it's a good question, is people end up selling their wallet. I think WorldCoin has like a major missed opportunity, honestly. So they take the iris data and they use that to create a private key, but that private key isn't used for anything. It's basically just used to basically encrypt the data, and there's like a whole flow with there's a whole thing with like creating like a unique identifier for the user that's based off of the session within their app at the time when they're registering, so that allows them to re-register if they ever lose their device or something. And the, uh, so they do that, and then they create a separate key set, and that separate key set is used to create a safe account chain, so a smart contract wallet. So you have all these layers of separation between the biometrics and then the wallet that they're using and the WorldCoin app. And the reason for that is safety. So the thing is, once you have a safe wallet, you can transfer that to anybody. You can transfer your safe wallet. You can basically, like, if I was in Kenya, and this is, I think, what has been happening in Kenya, if I was in Kenya and I was interested in farming WorldCoin airdrops in an industrial manner, I would go to this, to a distributor, buy 1,000 cell phones, and basically hire 1,000 people on the street and give them, say, like $10 and say, hey, I'll give you $10 now and $10 when you come back. Take this phone, go to that station, do what they tell you, and then when you come back, give me this phone back, and I'll give you more money than you've seen in a single day. Like I'll give you a month's salary, or I'll give you $10. Um, and so that's how people have been getting around it, is they've been actually just selling the wallet.
Okay.
Contains the proof in it.
Okay. All right. So now how's Holonym sort of taking a different approach to proving your proof of humanity that can't be bypassed with an iris scan or an orb?
Yeah, so there's a couple different things. So first thing first is we have a decentralized network that's an actively validated service called Mishti. Mishti is unlike any MPC network that I think has been, like, if you look at any ecosystem apps, it's always out in the corner on its own because no one's tried anything like this before. Mishti is a threshold network that lets you take any input data and derive very high entropy keys from them. So you can take biometrics, you can take face scans, you can take fingerprint scans, you could take any combination of data and use that to derive a key that you can sign on any blockchain. So it doesn't have to even be EVM. It's very agnostic. It can be used for anything. It's very powerful. And so once you have the key, right, then you can do anything on chain. But the key difference here, no pun intended, is that whereas WorldCoin is going through multiple steps and then creating a separate account that's not linked to the individual, right? It's just linked to the proof of the individual that created at the time of enrollment. The actual wallet is tied to your human attributes, which means that if you sold your wallet to somebody else, as soon as they logged out, they would need to represent those credentials again. So
To
you'd have to be
prove that they
selling.
were the same human that originally set it up.
That's
You can't just pay someone off the street to be a new version of Keli and then like buy the wallet and get two.
That's right.
Can you walk us through a little bit about how this would work on any blockchain? I mean, they're all so different. How does that, give me some examples of how that works?
Yeah, so different blockchains have different elliptic curves that they use to derive the keys. So, for example, with Ethereum, we use SEC256K1 to derive the keys, and any EVM chain that uses this elliptic curve will be able to basically have this like 0x123 type address. So that's why Polygon and Optimism and Arbitrum and all these different blockchains all have these 0x addresses, and why blockchains like Near and Solana, I'm forgetting which curve that they actually use. I think it's an Edwards curve. I think they use EDDSA signatures, and then Bitcoin uses Schnorr signatures. So what's cool about Mishti is that what it's doing is very simple. It's taking some scalar, and that scalar could be like a biometric data point, and it's multiplying that by a point on an elliptic curve that can be arbitrary. That elliptic curve could be the one that's used for EVM key generation, or it could be the one that's used for Bitcoin or Solana or another key generation. Edwards curve, or if you're trying to drive like Schnorr signatures, you can use any one of those. So yeah, it's something that you can do very easily. Now, the trick is when it comes to processing and dealing with transactions. And so that's why we built a wallet on top of Mishti that allows you to not only derive the key, but use the key very safely with specific blockchains.
Specific blockchains or any blockchains, because you've now got a key generated on any blockchain. So let's unpack this a little bit more in terms of, all right, I'm on the Mishti network. I'm assuming most, let's call it individuals, most consumers won't actually know that that's what they're interacting with. That's just something that now you've built a wallet that sits on top of this Mishti network, right?
Yep.
Most people, humans, individuals would come in and use the wallet that you've created to not to access the network, but to create a proof of humanhood that can go across any chain. So does this wallet that you've created sort of become the be all end all of entry points? And then how do you get into the wallet? And then how do you interact between different chains? Am I using the same sign-on for Near, for Solana, for Bitcoin, for Ethereum? Walk me through some of that from like just sort of an end user perspective.
Yeah. So this is what I mean by wallet as a protocol. So when you see Silk, the vanilla version that you interact with, it's basically like a white labeled version of the protocol. So I've taken all the bits and pieces that I care about for a particular implementation because no blockchain is the same in terms of its UX that's intrinsic to its block finality time, to um, how available, say, like RPC endpoints are, to whether they have resolvable addresses or, like Aztec has like stealth addresses. So when it comes to final wallet UX, it's not just unless you're a developer, then you can use Mishti really easily to create keys, and then you can program the keys to do whatever you want, right? But if we're talking about an end user who wants to just click a couple buttons, be able to transact on a blockchain, that experience at the very high level might feel the same. But for the developer that's shipping an application for that user, it's going to be very different, right? So, for example, with Near, you don't have Near is completely account abstraction built in. So you would need to do a social login first. And then once you have the social login, you would need to choose a username, a .near address. And then once you're in, then you're able to start interacting and making transactions. A big part of what we do for the wallet as a protocol to basically make Silk the most secure wallet experience that any user can have is we implement something called 2PC. If you haven't heard of 2PC or two-party compute yet, you will, I think, start hearing a lot more about it. Vitalik's been talking about it more in terms of like the end goal for wallet security. 2PC basically means nothing happens in a zero trust environment like a blockchain, like a Web3 environment or a DApp environment, if there aren't two redundant forms of authorization or authentication. So in our case, what we do is we have two decentralized networks. One is Mishti network that creates the key for the user. And then the second is a two-party compute, multi-party compute network called ICA, which was known as D-Wallet. And so these guys were able to solve this really difficult problem in cryptography that was thought to be impossible to solve, called the two-party ECDSA problem. And they showed that you could do this efficiently in an MPC network that can scale to hundreds or thousands of nodes. Today, any MPC network, if somebody calls themselves an MPC network, they probably have like 2 or 3, no more than 5 nodes, right? So being able to go.
But wait, this silly question though, but you're saying that the multi-party isn't as good as sort of this two-party compute, right? You have to boil it down to the two-party compute where you're able to do these forms of authorization.
Yeah. I think it helps actually, just to rewind a bit. So with two-party, you have basically two parties that need to authorize. So the user and the server. So the user can have one key, one half of the key, and then the server has the other half of the key. For any transaction to actually occur, the two keys need to be combined. For that to happen, first the user, in our case, needs to show like a biometric, needs to derive the human key. They need to show some biometric proof that it's them. And then for the actual transaction process, it would need to go through some AI transaction simulation like we've implemented right now to make sure that this transaction suddenly isn't unlike all other ones that came before. It's not interacting with a malicious contract. It's not draining the wallet. You can have all of these different qualifiers that can flag these, and if that occurs, then it requests a second or tertiary authorization from the user through text message or email, or maybe you have to like sign in with another wallet or a hardware key. So if this was implemented widely in practice today, then we wouldn't have seen the radiant that we saw with Safe a couple, was it 2 weeks ago? I think like $50 million were made out with because on, what was it, a 3 of 11 multi-sig. So they were, I think people think it was a state actor that did this because it was really sophisticated. But basically, the core dev team was targeted with social engineering that got them to download malware, which could have been as easy as getting them to download a PDF, like a safe. Like, hey, here's the safe.
But you only had to have a hit rate of 3 out of 11.
Yeah.
Yeah.
then yeah, all right. So you got the safe, you downloaded it. Now you're running malware on your computer, which means that this malware can, if you're going on safe, can inject HTML code into your browser. So you think you're seeing one thing, but when you're clicking confirm, you're actually executing a different set of code. So with the 2PC solution, you would have, even if there was malware on the device, you still have redundancy in this other server that is able to basically double check your work. And just to come back really quick to the MPC bit, so then you might say the problem is, okay, well, why should I trust this server? Why should I trust Holonym to run a server that's going to simulate my transactions and tell me what's good and what's not? So this is where 2PC MPC comes into play, where that server can be broken into a decentralized network, where it's very clear what they compute on, right? So if any node either falls off or somebody DDoSes attacks node or tries to like subvert the process, you would have to have all of those nodes in that network, or a good portion of those nodes in that network, uh, to be able to compromise the whole system.
Super interesting. All right. And then what does this mean for developers? You mentioned earlier that, the end user might not see this as a major situation, except they'll, things will be more secure, whether or not they care, or they just realize they're not getting hacked as much. But what does this mean for the developer experience in terms of building something out that is cross-chain, multi-chain, broader exposure and participation across the entire blockchain ecosystem?
Yeah, this is a really good question. I'm going to be giving a talk about this at a chain abstraction and intense day later this week at DEF CON. But
Nice.
so briefly, so Mishti was built to service other wallets. So any wallet, if they needed keys on any arbitrary signing curve, can make a request to the network, and they have this basically trusted piece of middleware for key derivation that's secured by Ethereum, meaning that you can trust that network to do its job just as much as you trust proof of stake and the amount of restaked ETH in that network, which at this point is $1.4 billion once we're at mainnet. So that's on that side. So devs can have tons of power, and we're getting a lot of excitement for those that really want cross-device universal accounts that if a user signs into their mobile device to access a dApp and then switches to their laptop, the experience is unified. You don't need to scan a QR code or export a private key or anything like that. You can securely and safely have a universal account that's as easy as just socials. That's using Mishti in the back. So for the devs that aren't, building core protocols from the ground up and need like a low level library like this, for devs that are building dApps and they want to have basically an a la carte menu of building the best experience for their user, that's where Silk comes in. Silk is this white labelable, basically iframe, where say you're Nike and you wanted to build a custom bespoke sign-in solution for you, sign in with Nike, create an account with Nike. You can use Silk and all the components that come with it to create a branded, very familiar experience for your users that utilizes Mishti for the key derivation, but has all of the security that comes with UPC and implementation of it. So for devs, it's something that we feel gives them the full set for interacting with any chain. The last bit I'll say is with 2PC, actually, you can take a lot of stuff that you would do with account abstraction. And with account abstraction, it usually means, like if you're talking about account abstraction in technical sense, not philosophical sense, it usually means you have a smart contract on one chain with all the policies and rules in it. So what happens when you have multiple chains? What happens if you change your default setting on one chain? You're going to have to send a transaction to each of the chains to change your, like say your profile picture or something, which is insane. So that doesn't need to be on chain. You can use MPC for that. And MPC is more, even more powerful than this, right? So you can actually, with two-party ECDSA, like a foregone conclusion, something that you can do, you can actually have a use case where with a Silk wallet, that's derived keys from Bitcoin, let's say, you can sign a transaction on Bitcoin. That transaction can be used with minimal trust assumptions to withdraw a loan on Cosmos. And from the perspective of the user, that UX is as simple as saying deposit Bitcoin, withdraw Atom. That's the promised land that we're building towards here. And we're not quite there today, but we'll get there.
Question that occurred to me as I was listening to you talk about all this: what's your philosophy on the spectrum of, identifying you're a human and this is who the human is versus remaining anonymous?
Yeah, I think you can do both. I think I believe that like a lot of cypherpunk, and anonymity sort of like, it's a lot of his like reactionary knee jerk sort of like culty type canned responses that, oh, I can't show anybody any of my information because I need to be private, right? But in reality, every time you create an account, you're giving away a data point. When you create a Bitcoin wallet, you're giving away that data point. Well, that's what we call a NIM. So, best practice for Bitcoiners might be, every time you transact, create a new address or use a new address. Now, that's great if you're just using Bitcoin to store value. That's fine. Nobody really cares. That's totally fine. But when it comes to building an ecosystem of value of an app store on chain, like with Ethereum and all these dApps, you can't have that same sort of experience and also expect that all of the use cases we imagine are going to thrive. So a really great example of that are airdrops, right? So everyone sees airdrops as this, at least one point, everyone saw these airdrops as a new financial mechanism, a new way to growth hack, a new way to take Web3 out to the masses. But airdrops show that it's really easy to game any sort of like system. It's like Goodhart's law, right? Like if there's any metric that you're using to optimize for, somebody's going to find a way to game it. And that's what happened. You have the emergence of these industrial symbol farms that make hundreds of millions of dollars, pretending to be individual people. So this is a huge problem. It's been very difficult to solve, but it is possible to solve with privacy. So the way you do it is basically you have somebody, for example, the most private solution would be to take the way you could do this with full privacy is take a passport, tap that passport to your phone, read the data in the passport, and then do on the phone a liveness check to match that your face matches the biometrics that are in that passport. Now, keeping all of this on the device, you generate a zero knowledge proof that you have ownership of that passport. That passport is signed by the State Department, and that you followed an open source algorithm, a protocol that anyone can verify to check that the face matched with the data in the passport. You can bundle all of that up into a nice little zero knowledge proof, and you can post that proof on chain that anyone can verify. So the only
without
thing
actually knowing your passport number, what country it's from, your middle name, all that jazz, your birthday, all that.
The only thing that would know it is the phone. The phone
Right.
would be and if you could set it so that the phone deletes all the data once the verification is done.
Right. And for most use cases that you're trying to drive to in the promised land, there's a bunch of them that will be just fine for.
Yep. And we think so this is, if you tackle this problem, if you can show you can do these like proof of humanity with very strong privacy guarantees, it's not perfect, right? Like you can still attack the phone, you can physically attack the person. That part's not perfect. But if you can show you can solve this and, to a point, this very difficult problem, then it opens up a whole world of use cases for when we want to take crypto to mainstream real world applications.
Amazing. Congrats on the momentum and success so far. What comes next for Holonym?
Yeah, absolutely. We're really excited about some of the hackathons and residencies that we're sponsoring, building at the intersection of human rights, blockchain, everything that's going to bring a lot of good attention to the space and remind people why privacy is important. We're really excited about hitting a couple targets. We have some kind of some news in the works around. We're looking to hit about 1.6 million users next year through some targeted campaigns, and I'm not going to give any more information about that. You guys will probably hear about it soon by the time this is out. So we're looking to grow very aggressively within the next 6 months. The time with the launch of Mishti Network Mainnet, we're actively onboarding operators right now. So we have a really great solid set, very well trusted, reputable, competent organizations providing infrastructure for us, and we continue to expand that. And I think the really big moment is going to be when Silk comes out of beta, and we were working and talking with folks that are running special economic zones. I don't want to give away too much information because this stuff is still, I don't want to give away too much, but I'll just say that there's a couple countries out there that are really interested in building up their civic infrastructure from the ground up with crypto security.
Amazing. Where can our listeners follow along for more?
Go to holonym.id and everything you're looking for can be found there.
Wonderful. Shady, thank you so much for joining us today. Appreciate you being on the show.
Thank you, Keli.